the requirement of virgin stone aggregates is such huge, mostly from the requirement of highway construction, and equally other infrastructure sector has also huge demand. So to meet these both requirements, it's a kind of win-win situation if we can make steel slag gainfully used for road construction. To start the process, this guideline was genuinely very important. Without that, for any field engineers, for any authority engineer or independent engineer to allow use of steel slag in substitution of stone aggregates was a bit difficult. I hope this guideline has done a great service.
I accidentally came in connect with this slag road. I was working in a project and suddenly I needed a fill-up material in West Bengal, and I had there is no earth available for fill-up. So I said, we see, as was told in the first session, that I had seen that in Durgapur, heaps and heaps of this slag material. So I said, why not fill this up?
We say that steel is recyclable, but not like that. Now we can say the waste which is being generated from the steel making, that is also recyclable, and it is a step toward the sustainability. I request to Mr. Pandey that our industry, they can come forward and submit the project so that we can work further, because in future the slag generation is going to be more, so that we can have a further more solutions for it.
So at present, we require around 1.2 billion ton natural aggregate annually for the construction and maintenance of road network. So this steel slag can partially satisfy the demand of natural aggregate and can be utilized for the road construction work. So from bottom to top, every layer of this road is built through steel slag aggregate only, including road median and road shoulder. And one of the important feature of this road is that it is constructed with 32% reduced thickness in comparison to the thickness prescribed in IRC 37/2018 for 100 MSA design traffic. So this road is around 30% thinner than the conventional road, which makes it more economical. This is the Mumbai-Goa NH66 Mumbai-Goa, and the LHS1 is the cement concrete section, and the RHS1 is the bituminous concrete steel slag road section. BRO 0 road border road organization, this one we built it along with BRO, and here we laid the 40 mm thick bituminous concrete using processed BOF LD slag aggregate along with surface modification technique.
Even yesterday's flash flood type of rain is absolutely no comparison to the rain that takes place in Arunachal Pradesh. As we sit, two people can't even talk to each other when it rains there. It is so heavy. So with that in mind, we tried out this technology in 1 kilometer stretch of the road. We identified a road stretch, and then the biggest problem was how to get the material. We are thankful to Tata Steel. They offered us this technology, this material free of cost. Some views of the completed road. You can see this blacktop road constructed using steel aggregate. This is a view of the site inspection. Dr. Saraswat from Niti Aayog also visited us, and the biggest encouragement came from the Honorable Prime Minister himself when he tweeted that infra creation and circular economy both will get an impetus. This was based on the BRO tweet which the Prime Minister retweeted.
We are also one of the biggest beneficiary of effort of CRRI in terms of utilization of steel slag on our road. And in order to utilize that in a bigger and regular manner, we did a trial patch of 1 kilometer of bituminous and 1 kilometer of rigid construction of pavement of 4 lanes on Mumbai-Goa road. And this section was selected from point of view that this is one of the busiest section with many industries along the road and heavy containers moving on this, and this section is on Western Ghat and witnesses a rainfall of 5,000 millimeter, which is comparable to our northeast states. So ideally this section, if it succeeds the trial, then anywhere else it can be successfully utilized. These were the tests which we carried out on the road last year. 3-4 days before I travelled on that road. The road is perfectly fine and it is meeting all the requirements of skid resistance. Now rains have started in that location. Tires are not skidding on that. I think 15 days before, it is exactly 1 year when we completed that section, and the road is perfectly fine even today. And we have requested CRRI to come again and do the testing of that road section.
While I was on driving, a very important quote came to my mind. I hope you might have seen this, which was quoted by former US President. He said, "We are the first generation who is feeling the impact of this climate, and we are the last generation who are supposed to do something." I think this event is something in that same direction. I represent the steel industry, and being from steel industry, we feel that because of the nature of the process, we are a little bit more responsible to do something about this, and many actions are being done. And today my presentation is one such incremental step which we have taken from the steel side to do something on the climate change, which actually fits into the theme of today's presentation. We have an alternative product to save the environment. The river sand comes from rivers, the M sand comes from the mountains, but we have an eco-friendly sand which comes from our byproduct, and that's how we contribute a little bit to this noble cause going forward.
Very proudly we can say we are the first to take a risk to make a road of 1 kilometer using steel slag. Behind there is a story, there is something which has given us that confidence that yes, this will work, and the confidence on Dr. Pandey and the entire CRRI team that yes, together we'll make it happen. Some of the glimpses of some photographs from the beginning, the road was in a very bad condition, then slowly different layers were laid, and at each stage of the development, Satish Pandey was always there, assessing the situation and how we can measure and study. And finally the road was developed and inaugurated, and we got the first this in the Asia Book of Records certificate also. The road is now 3.5 years old. It has seen 3 to 4 rainfalls and not a single pothole on this road in the entire operation journey. You will be surprised that in the last 3 years we have sold more than 47 lakh tons of processed steel slag from our Hazira premises, and yearly we make around 17-18 lakh tons of processed steel slag. Now we are also exploring different applications of the slag, like tetrapods, pavement blocks, precast concrete, encatchment areas, gabion walls, and we are also developing products which we are using in our own expansion projects.
I hope in IRC will be able to take forward this standard, and it can have more applications in the road building. Thank you.